Hi everyone, are you excited to start this lesson? It's alright. I need to give a little bit information to you. So before start lesson, I'm a little bit sick. I got flu, so I'm not feeling perfect, but I will try my best to explain everything correctly to you. Okay? We already finished it. We already completed two conditionals part. Now, in this case, in this session, we will learn about logical equivalence. This is very important. The past lesson, I explained to you how you can make if else's in nested way, like how to make and with like if inside it, and how to make or like if in the same column, like it's going like that and in desk so and else looking like not if you make something not. All right, in this case you will learn how to make from not or to end, not end to or. So anyway, maybe I mixed up your brain, but please don't leave from this video and let's start it. Let's learn everything correctly. So if you have any question, please write in comments. So your description, then I will read all of them and I will answer. All right. Okay, in this lesson we will make practice. So we will learn theory and after that we'll make practice. Theory, practice, theory, practice. I got all this information from Khan Academy, but there is exactly no practice part. For that, I will just show you how to how you can understand in easy way in the programming what's going on. All right. So that will be perfect, I believe. Okay, because so yeah, it will be nice. I believe that so. So let's see what we have. Okay, we have in here practice HTML, like logical equivalence practice HTML page, which is I open it in here. Already this style, which is it's explaining like JavaScript. So in here we just start to write the codes, all right, and after that we'll continue with the steps. So also I have here, by the way, it will be not style, I'm sorry, I just mixed up it. All right, so just it will be script. I'm looking why it looks like that. All right, so by the way, I'm doing an internal place and I don't want to make it like external. So let's see everything in the HTML page and everything will be nice for you. And also this is Python. When I complete some steps in here, I will continue with the right side. So I will bring it like that and we will work exactly on here. Okay. So we can say logical equivalence, uh, right, practice with Python. Yeah. So what we can do right now, let's take it right and come back to here and let's start lesson. Maybe in the first part we will not do anything else like a practice, but just I will teach you theory. All right. So introducing logical equivalence. This is our first subtopic. Logic is both an essential a part of computer science and our everyday interactions and logical expressions help us make decisions both in our programs and our lives. That's exactly true. Let me take my pencil to put there some tick. Like, yeah, that's true. Take, for example, this statement. All right, let's look. Let's come down slowly, slowly. All right. You cannot go to park if your sister is awake. If your sister is awake, you cannot go to park because she will scream, maybe she will cry or something else, okay? In programming, we can say if, like if sister, okay? If sister, then we can put some variable like awake, like in strings. If sister equals strings in strings, you can say awake, or in so in variable. So then we can say you cannot go to park, right? This will be our instructions point. You cannot go to park. And if sister equals awake point will be our conditionals point, right? Instruction, let's say instruction condition. All right. This is logical expression that declares the criteria for going to the park. It's fairly simple since it only requires a single condition, your sister being away. I told you this is condition. Like, bam, if it is really true. To make more informed decisions and handle more possibilities, we can combine multiple logical expressions. Consider this compound statement. Let's see. All right. Thank you. You cannot go to park. Yeah, this is our instruction. It will be in print or console.log. If your sister awake, like if sister equals awake, or we can do it in nested way like in the same desk, right, like that, or we can do it like if sister is awake or and blah blah his room is dirty, right? Now we have two conditions in here. One of them can work, like if sister is awake, you cannot go to park. If room is dirty and if your sister awake, so let's think here. It is not and, okay? If your sister is awake and if your room is clean, you can. Do you think you can go park? So let's think about it. So because we have two conditions here, if your sister is awake or if room is dirty. Okay, one of them can be possibility. Like one of them have to be true. So if your sister is awake and if your room is clean, you cannot go to park. Or if your room is dirty and if your sister is like sleeping, so you cannot go to park. If your room is clean and if your sister is sleeping or awake, let's say awake, you cannot go to park. So that tells us when. So let's say this is conditional part and we separated two conditions like awake or room is dirty. Like room equals, like if equals dirty, and if your sister is equals awake. All right, let's say here we have or. If this situation is like that, then it will be like that. You cannot go to park. If one of them true, you cannot go to park. If all of them true, like you cannot go to park. If one of them or if both of them false, you can go to park. So let's say like if your sister is sleeping and if your room is clean, you can go to park, guys. So you can go to park again if this is our conditions. So instruction. If your sister not awake, like it will be sleeping. Not awake mean sleeping, right? Sleep. If your sister not awake, so if sister is, like if sister is sleeping and your room is not dirty, like your room is clean, it means you can go to park, right? It will be clean because it's saying not dirty. It's like what? So not dirty mean, so it's clean, right? So I will teach you something before that, because we are applying here, like in math we have minus in parentheses, which is for the distribution of them. Let's say it's saying not awake, like not awake, and not end, like not awake and not end. All right. And if your room is not dirty. All right, if we use it, it will be plus in this case. It will make this, so in this case, if we multiply it, like if we distributed, it will be like what? It will make it, let's start with the first one. Like let's add for all of them, not the first point. If your sister is, let's put here also not. It is also not time, not like you can think like that. Then sister have to be what? What? Not awake. If your sister is not awake, it will be sleep. All right? Like minus minus will make plus. The plus mean will be sleep. Minus mean will be awake. Okay? And not and here also apply for here. Like I show you in math, we have distribution of the minus before. So it will be not and will make or. All right? Not and will be or. Anyway, so just don't mix up your brain. Just guys, I made little early that things, but just don't worry, okay? Wait. Just wait me. So, and this one will be not dirty, like not time, not will be like plus, okay? Then see it like it will be clean, all right? So, okay, now our things happened like what? If, like if, all right? Sister is sleeping, like if sister, let's say sleeping, sister sleeping, like that, and we made it not and have to be or in here. Let's say or, I'm just making short case, or uh, if room, let's say room is clean, room is clean, you can go to park. Did you see that? So it is like in math, minus minus will make plus, and just apply for all of them. You'll see everything correctly, all right? But I will show you all of them. Okay, just don't worry. Just wait. I just showed you a little early. Maybe you will be a little crazy for thinking part, but they are all coming from a person logicist. Let me show you. So anyway, I will tell you the man name. But before that, De Morgan's. Yeah, this is De Morgan's laws. Okay, De Morgan's laws. He's logicist and he just explained it everything. He's Greek. All right. You can go to park. This is instruction. If your sister asleep and your room is clean. So it's saying if your sister is asleep, like awake, and your room is clean. So if this and this situation true, you can go to park. If one of them wrong, you cannot go to park. Let's remember, if you put there and, everything have to be true or false. If you put there or, everything like the one of them have to be true, like from all these conditions. All of the above three statements are considered logically equivalent. If one of them is true, the others are true. If one of them false, the other is false. All right. If we apply here also not sleep, it will not asleep. It will be sleep, and not and will be or, like sleep or, not clean will be dirty. Sleep or dirty. You can go to park. All right. Logical equivalence. This is a crazy topic. Let's continue for there. Logical equivalence is the idea that more than one expression can have the same meaning but have a different form, often a form that helps makes the meaning more clear. Imagine that your parent is a computer scientist and wants to both test your responsibility and your understanding of logical equivalence. Such a parent might respond to your question, can I go to the park? With the following statement. You cannot go to the park. It is our instruction. Yeah. All right. It is a little crazy. Yeah. You cannot go to the park. And if conditions what? If there is not more than one parent, like if parent not greater than one, it means okay, not more, not more than one parent. So it is not equals, like if it is not greater or equals than one, we will say okay, more mean greater, okay, it will be something else like that, not greater or equals. So it is greater, this is equals one. So one parent mean one, all right. If there is not more than one parent, okay, is parent if not greater or equals than one. And if your sister, let's say, and in here we have and, if your sister, if your sister is not asleep, so let's think about that. What will happen in this in here? Just think about it, all right? So if your sister, we put already and, if your sister not asleep, sleep asleep, all right? So if it is sleep, you can think it like that. So like sleep, and you can say sleep for it, okay? Or not will make and, let's say for it sleep, all right? Or not will make and in here again, okay? By the way, why I'm doing like that? Let me do one more thing for here. I will do one thing for here. Sorry, guys. Okay, I will say for here exactly front of you. So we will do something else like that. If, like in JavaScript or in Python, let's think about if parent, okay, let's say parent is greater or equals than one, all right? If not more than one parent, it means if greater than or equals. But you need to say if there is more than one parent. It's not saying it. Sorry, I'm so sorry. So if parent is less than or equals to one, okay? If it is one or less, but it's saying like if there is not more than one parent, home. So if it is only one, you cannot go. So it means if parent not more, it means like less than or greater, less than or equals to one. All right, and after that we saying and, yeah, and let's do it in JavaScript like that. And if your sister is not asleep, it's like sleep. If, and after that, if sister is sleep, okay. But we have here also and, yeah, if sleep as, also we have or not, it will make if sister sleep, let's say in here, and sister, yeah, sleep, okay. Let's think like that. Sister sleep, let's do it like that. If sister is sleep, by the way, I'm just opening this meaning of these things, okay. asleep or not, like and, it will be and. 1 minute. Just let me come here. All right. And least one parent is home or not, and at least one parent, like parent equals one. Okay. So this will be something else like that. Okay. So how we can separate? If you see, we have here some large like ways, but it's like if there is not more than one parent home, and if your sister is not asleep, or it's going all the way like and like that, then you cannot go to park. Okay, it will be something else like that. So yeah, even with just two conditions, the number of parents home and your sister's sleep status, I told you. And if I have logical operators, not and or, it has become very difficult to figure out when you go to the park. Here's a statement that's logically equivalent but much clearer. You can go to park if both parents are home, if they are really in home. Yeah. If both parents, if both parents, like we can say in here, like if parents equals 2, okay? If parents equals to 2, or if your sister asleep, yeah, so if your sister asleep, and we can open another parenthesis, or and list one parent is home. Yeah, we can say if parents equals 2, or if your sister asleep and at least one parent is home, like we can say the parent is 1. Okay, now we have the freedom to go to the park, understand otherwise cryptic role. This idea of logical equivalence is very important, not just in rules for life, but in computer science, where logic and rules are at the heart of the creating useful tools. Next, we'll explore the many ways of making logically equivalent expressions in code using simple Boolean expressions. It will be our first topic. So let's do like that. Compound Booleans expressions, if as conditions, everything combined. We will see for topic again, okay? So the another topic will be equivalent simple booleans. So we will go step by step with them, all right? So after this topic, we will start for another topic, all right? You'll see everything correctly with me. Okay, let's go to the here equivalent simple booleans. Yeah. So we will continue from here, but did you understand everything correctly? So if your sister is doing something, like if your sister is awake and if your room is dirty, just don't go to the park, okay? You cannot go to the park if your room is clean, but we put there some not and something else, not and or not or, some like words. For that it will make your brain little different, like difficult way, but just don't worry, okay? We'll explain everything. Just you need to know one thing in here. I told you in math we have distribution of the things, like minus minus will be plus, minus time minus will be plus, minus time plus will be minus. Like you need to know that. So if you put there not meaning like something else, minus, like negative, right? If we apply not time not, it will be like minus time minus, it will be plus. Like if not dirty, it will be clean, right? Like minus minus will make plus, like clean. Nine, like negative will make positive. All right, it's just applying there's some rules in this case like that. All right. All right, guys, let's start it. So, the second subtopic, equivalent simple booleans. Let's do some practice. I will teach you something right now, how to do these things in Visual Studio Code. All right. A logical statement is equivalent to another statement if it is true in the same situations that the other statement is true, and false in the situations where the other statement is false. All right. Let's start off with some basic logical equivalence. This may seem simple, but they will serve as important buildings blocks more for more complex logical equivalence later. All right. So equivalence with not. Right, let's start with not. This may be the true simplest equivalence rule. Equivalence not true equals false. Not false equals true. So if something not true, it will be false. Yeah? Did we understand that? Right, that's perfect. So okay, if something not false, like yeah, your car is going, like let's say you're running from someone like in our with 5 miles, and if we can say like if your run speed is greater than 5, like greater than 10 miles, uh, so in this case, let's say your escape acceleration or escape speed is 10 miles, and we are asking about 5 miles. If greater than 5 miles, it will be false. If we add there not before these conditions, not if your speed not if your speed, let's say if your speed not greater than the your escapes escape, I just mixed up. I'm 1 minute. Like let's say we will put there, I mean let me show you, like we can say if, all right guys, this is logical things and it's making a little hard to understand. If your speed, let's say your speed, it's greater than 5, okay, greater than 5, let's say your speed is 7, then say here in instruction we can say you are very fast, right? You are very fast, anyway you are fast, okay, let's say something else like that in instructions, in print point, in console dot like point. So what we say, like your speed is 7, and the general speed, I mean average speed, have to be 5. Like you cannot escape like greater than 7. Let's say in this case it is true, right? It will work. And what if we say not before that? Like if if not, yeah, if not. So in this case, in JavaScript, it will be like that. You know already that, right? I just wrote it like pseudocodes. So if not your speed, your speed greater than 5, let's do it like that. Yeah. So in this case, our speed is greater than 5. It is true, but if we say not true, it will be false. Like if false, like it will be else. Exactly, yeah? So it will not work for here. It will be false conditions, okay? So because your speed is greater than 5, it is true, but we put there not to make it false. So your speed is 7, and this is greater than 5. That's really true. I join you. But we saying if it is not true. Not if it is not greater than 5. So if it is not true, it will be false. All right. For that, we have different rules. So let's say it is 3. In another case, let's say it is 3 and average speed is the 5. Same. It will be what? It will be false. If not false, it will be true. All right? We can create these conditions also like that too. I told you it will make minus minus like plus. So in this case, minus minus will be plus, and in here what we have false conditions minus minus. It will be true. It will be positive. In math, I told you if it is minus plus in distribution, it will be minus. Yeah, and if it is minus and minus, if we multiply them, it will be plus, like positive. And if we like make it minus time plus, it will be minus, like negative, right? That's logical equivalence. I hope you understood. Whenever we see the expression in the first column, we can replace it with the expression in the last column, and our logical statement will have the same meaning. Please don't stop in here. Just try to listen this lesson. Okay? Maybe it will be a little bit tiring, like it will tiring you, but just don't worry about anything. Okay? We will solve all of them step by step, and you'll understand everything correctly in convenient way that should just make some experience. So just don't worry. Okay? Just we will deter all your concerns for about that. The following statements are logically equivalent according to this rule. When is hot, like when is hot out? If out is hot, not true. I wear a sweater because it will be winter or cold, right? And it's saying if it is not true, then it will be false. In false conditions, in negative conditions like raining or snow, we need to wear sweater, right? Sweater. When is out, when is hot out, like when out is hot, then so we need it's false. I wear a sweater. It is same things. When is out is like not true, like this one, not true, like not true, and false, same. If it is, it's saying when like outside is not hot, not hot, then I wear a sweater. When outside is like outside is hot, meaning like when sometime when someone's saying like outside is hot is and it is false, I wear a sweater because it's the same situation. All right, same, not true and false. Not true equals false. They are all same. Two nuts. So in this case, we made something like minus time plus. Yeah, like that. Let's put here minus time with the dot plus it will be minus like false. Now let's look for two knots. What will happen? Let's see it. This is very important. It will help you. The programming and math working together, guys. Two knots. It is also important to know that two not operators, not an expression, have the same value as the expression without any not operators. So equivalence, let's look here. Not A. So in this case, we are saying not A, it will be B, right? Let's say B. If not B, so let's put it in here in parentheses. If not B, not B, it will be again A. Do you understand what I did? If not A, it will be B. It can be B or C, whatever. Let's think like that easier. If not B, it will be A again. So it means minus, let's say in here, minus time minus will be plus. Yeah? Not A will be B, right? minus a, let's say like that. It is minus a, minus time minus a, it will be plus a, like this one. All right. Plus a, it is same like a. All right. Not mean like minus, minus, it will make plus. Okay, not equal, not equal, looking like what? When programming, it's also possible to apply not to the result of an expression using the equality operator. So let's do it in the practice. We have two variable in here, right? So let's do it together. So when programming is also possible, I just did the same thing. Not speed limit is equals to car speed. So I think in here it's not making something else like speed limit normally equals to car speed. It's saying like plus, but if you say minus time plus, it will be minus. So it means normally it is plus. So I mean this situation is plus. All right. So this situation is true, but if we say not true, it will be false like that. It means false. Like if speed limit, like the not say it, if speed limit, let's say if speed limit not equals to car speed, because we are saying here speed limit equals to car speed, but if we put there not, it will be if speed limit not equals this one in here, right? Not equals to car speed. So it will be like that. Programming. So in other words, check if speed limit is equal to car speed, then apply not to the result. This expression will be false when the variables are equal to true when they are not equal. Programming languages typically include another operator to describe the same idea in a quality operator. That's totally true. Let's come here. It is in operators, like with operators, the another one with logicals. So, or in verbs, check if speed limit is not equal to car speed. These two expressions describe the same idea as we have another logical equivalence. So, equivalence A equals B. It is true, right? It is true. And put in parentheses A equals B, like A1, A equals 1, B equals 1. It's saying if not A equals B, then like let's say like 1 equals to 1, but if not 1 equals to 1, it will be exactly A not equals B. Alright, in this case. It means we will say it is plus minus 10 plus will be minus, like not equals exactly this K point in here. Sorry, guys. By the way, I will make practice for the another topic. Okay, after this topic, you'll see the practice in exactly in here or just in equivalent component booleans. So I'm sorry. Sorry, guys. I got flu for that. I'm feeling a little bad. I will stop video 1 minute. Yeah, guys. Which of the following statements is true? Choose all answer that apply. We are looking which statement is following true. We are looking for true. So A not equals A, not A. So A equals A, it will be true. Yeah. And we have not in here. So if we say, so let's say for that plus A equals A is true, like plus or true. Okay. If not, this not will represent minus. Minus time plus, it will be minus. So it means it will be false, right? If so, A equals A, True. If not true, it will be false. That means that it is false. Not true. So if something is plus in here and it is minus, it is the same situation. So it will be exactly minus, like false. All right. This is again false. Yeah. In here we have minus, not representing negative, minus time minus will be plus. So not false will be in here true, right? Let's do it like that, guys. If like the situation is not false, then conditions have to be true. And if we here say like if not true, it will be what? False, right? So if we apply here not true, so yeah, say not. And in here just close it, it will be false. Not false, true, not true, false. It will be false. Not false will be exactly true. In here we're saying not false will make exactly equals to true. But let's do in math, in logically, okay? In physically. Alright. Not will represent negative, false will represent negative, minus time minus will make plus. So it means it will be true, right? That's true, guys. So let's check again. Not false, true, not true, false. Not true will be directly false. A equals A is true, not true will be again false. All right? And the first one, A not equals to A. Is that true? Do you think is that true? What do you think? A is equals to A. Is that true? A can be equal to true. A. That's false too, right? Yeah, let's come down. Not less than, not greater. A similar idea can be applied to the less than and greater than operators. Consider these expressions, alright. If car speed like 5, let's say 5, and speed limit is 3. So car speed is less than speed limit. Do you think it is true? Car speed is less than speed limit. What do you think? Negation. We will apply negation, right? If car speed is 5 and speed limit is 3, we are going a little fast. So it is false conditions, right? Because car speed have to be great, so like less than speed limit. Okay. So if car speed is less than 3, it will be exactly false conditions, right? False. Car speed less than speed limit. So it is 5 and this is 3. So speed limit is not greater than car speed. In this case, it is false conditions. And if we say it is not false, like not false, it will be true. Yeah. But what if our car speed is 3? Let's say it is 3 and the speed limit is the 5. In this case, what will happen? If car speed is less than speed limit, yes, this is true now. Yeah, let's say true. If it is not like before, apply it. not true, it will be false condition. So exactly. So if we're writing some codes, we can say in instructions place for the else conditions, okay? False. And for the if conditions, this true or whatever. So or in words, check if car speed is less than speed limit, then return the negation. If car speed is less than speed limit, the whole expression is false. All right, false. Like what? We did here. Did you see? False in here. So if car speed is less than, which is in this case we set for speed limit 5, for car speed 3, so 3 is less than 5, it is true, and not true will be false. In this case it's saying if car speed is less than speed limit, the whole expression is false. Like I said, as I mentioned before. Any other relationships makes the expression true. Like I said for car speed 3 and for speed limit 5. If like 5 less than 3, it is not true. It will be false. If we say not false, it will be true. Like minus time minus plus minus plus minus time plus minus like that. All right, let's walk through this example with real values. Let's do it. Come here. Say var. All right. After that, say car speed. Car speed equals what? 50. All right. And speed limit. By the way, you can use lat or const for here, but const will never change. Anyway, I will explain everything in the future. So say var speed limit equals to 40. Speed limit is 40. We are going very fast with the car like a 50. So let's create conditions in here. We are saying if car speed less than speed limit. Do you think the speed limit is less than car speed? So car speed is less than speed limit. In this case, car speed is greater than, so it will be false. Yeah, it will be false. Do some actions. We can replace the variables with their values, like not. Let's do not in here. Let's apply it like that. What will happen? Normally, so let's do it. If, so sorry, yeah, heart speed less than speed limit. Oh, wait, it's not reading. All right, let's, yeah, let's go. So there we go. Car speed is less than speed limit. Car speed is less than speed limit. Do you think it is true? Car speed is greater than speed limit, right? It is false, but we have here not. It is saying if it is not false, it will be true. Like true. This is true condition. So let's see what I mean. Since 50 is less than 40 is false, the inner partition is false. Not false will make true. I told you. This is, it will give here true instruction. Okay? So then we negate false to find the final result. So let's say for here it is true. So it means we have here what, like for if, let's say not is the negation, like let's say minus, and we have here, it means that, all right, just do it together. We have here some expressions like that. Minus time and car speed is less than speed limit. In this case, it is false. Minus time minus, it will be exactly plus, right? If you apply it there. And if it is 40 and this is 50, it will be true. So the conditions will be like that, minus, plus, and it will be exactly false. So in this case, if we do it like that, it will be false. Did you understand what I did? I hope you got it. All right? Just think about these things, operators, what I did. Like not representing minus, not in here the false condition. So in by the way, we just set for here 50 and for here 40. In this case, the conditions will be false, which means we are representing with the minus, and minus time minus will be plus, which means true. So if we make here like 40, let's say 49, it is then 50, and in this case 49 is not greater than 50, so but speed limit is the greater than car speed, it is true, so it is like true, and we have not here, it is negation, so it's representing minus, minus time plus will be minus, like false. So in this case it will be false. All right, so it's exactly changing for conditions, changing according to conditions. I'm doing my best to explain everything in good way. Yes, guys. So it is true. I told you before. Similarly, if car speed was 40, the result will also be true, and not true will be false. As you might see from this example, an expression of the form not a less than b, it will be a greater than or equals to b. So in this case, we can say the meaning of this expression, it is like what, if current speed is greater than or equals to speed limit, okay? It means that. So it means like not less, like car speed not less than speed limit means exactly if car speed greater than or equals to speed limit. All right, just think this value like before, right? Like that. So if it is not less than, it must be greater than or equals. If it is not less than, so like here, it have to be greater than or equals to speed limit. Yeah. So it is true to the false conditions like that. So in this case, think it like that. All right. Not false will be true. Pass. So it is same thing. Sorry. This is also same. Like this is same expression and this is same expression. All right. So let's come down what we have. It should also make sense that the rule holds for the other pair. If it is not greater than, it must be less than or equal. So in this case, let's say let's tag all these guys in. All right, let's put their back. This is our key point. If it is like okay, in this case, let's change here values like that, like 50, 40. Take screenshot, guys. Okay, this is very important. If 50 is like, let's say, if 50 car speed is greater, like less than speed limit, in this case, it is greater. So it is false conditions. Not false will be true, exactly true. All right. So in this case, it is here for here. It is car speed is not greater than speed limit. So greater, like if car speed is less than speed limit, it is true, and not true will be false condition. So in here, and it will be like that. Let's say if car speed and less than speed limit, So it is exactly card speed is there. True, not true will be false. Not true will be false. All right. Then card speed is the greater than or equals the speed limit. Okay. The the expression will be like that. And in here, if card speed is less than speed limit, in this case, card speed is 50, speed limit is 40. So it is wrong, false. Like not false, it will be true. In this case, what will happen? What do you think? It will be minus. So it will be not false. Like car speed is less than speed limit is false, right? Car speed is less than speed limit. It is false, not false will be true. Okay, this will be true like in here. So let's look for another, this one again. Car speed is less than speed limit. Yeah, this is also true. In this case, car speed is not less than speed limit. Yeah, speed limit. Car speed is not less than speed limit. Yeah, I understood. Right. So car speed is 40, speed limit is 50. The 50 is greater than car speed. So in this case, the true conditions working in here. So speed limit is wrong. So speed limit is 40. It is not less than car speed. So greater than car speed. So it is false. If not false, it will be true. So if car speed is less than speed limit, not less than speed limit, if not false, it will be true again. In this case, it will be greater than speed limit, right? So it's all about these conditions, guys. Okay, just you applying same things. Okay, everything is in this case true for the situation. It is like 50 speed limit. Then this, if car speed is 40 and speed limit is 50, um, in this case, I just mixed up little. Sorry, like I know just logical way, but I'm little sick. So okay, anyway, so if car speed is less than speed limit, it is true. Not true will be false. All right, not true will be false in this case, and so we can say for it like is car speed is less than or equals, right? Not greater than or equals. All right. And in here, our card speed is 50. It is not less than. It is false. And not false will be true in this case. Okay. It will be plus again. And it will be again same. Like card speed is. Oh, what I did. 1 minute. Come back here. So I think if you change this operator, everything will be good. So anyway, I hope you understood. If card speed is less than speed limit, in this case our card speed is 50, it is not true. Like not true will be false. All right, we will say false. It's false. And the card speed is less than speed limit, it is false. Then it have to be greater than or equals to speed limit, right? So you can understand all things like that. If car speed is not less than greater, not less than speed limit, car speed have to be greater than or equals to speed limit. It will be like that. And in here, in up, just value is different, very in variables. If car speed is not less than speed limit, it have to be greater than or it. Okay? Just we can change it like that, and it will be exactly plus. Let me show you one more thing. And if it is like that, it will be minus, it will be less than like that. All right, that's all, guys. You can tag screenshot for that, this one. Just take screenshot for the page. It is not greater than, it must be less than or equal, like I did. So the rules equivalence is the same in here. If like A less than B, if not A less than B, A have to be like A has to be greater than B or equal to B, right? So yeah, if A greater than B, and if we say if not A greater than B, like then it will be A less than or equal to B. Yeah. So just we need some variables while you're here. Anyway, equivalence with less than or equal, and greater than or equal. The symbols are less than or equal and greater than or equal to are short case for longer expressions. When we speak the names of these operators, we say an expression like less than or equal to, and in fact that gives us another set of equivalence rules. Equivalence. Let's see what is our equivalence in here. All right. It's saying what? Equivalence. A less than or equal to B, like A less than B, or A equals to B. In two possibility, the pattern is that A can be less than B or A can be equals to B. Okay? And like that in here. So A greater than or equals to B, like A can be greater than B or A can be equals to B. Like that. Let's say A is 5, okay? 5. And B is 3, or what? Or 5, or 6. Yeah. It's saying like A less than or equal to B. A less than, it is true. Yeah, this one true, but not equal to B, right? It is false. But if one condition working for all logic gates, it will work for the conditions, right? We can say if A less than B, or like if A less than or equals to B, do some instructions. It will work for because A less than B in here, right? A less than B. A is 5, B is the 6. And another one, A greater than or equals to B. A is not greater than B. In this case, it will be wrong, and but A equals to B. So do you think A is equals to B? No, it is also wrong. So, but what if we say so? In this case, the whole expressions is wrong. There are not will be not any instructions. So, but if we do it like 7, what will happen? If A less than B, not less, it will be minus, and A equals to B, there's also minus. If A greater than B, it will be true, and B equals to 6. No, it is also wrong. 7 is not equals to 6. All right. I hope you understood everything. It's all about variables, guys. Just remarking with operators, all things easier. We don't need to write like A less than B or A equals to B. It is very easy to make it like like that, or like that, or like that. Okay? In this case, in pseudocodes. In programming, it will be like that, or like that. Okay? That's all. Check your understanding. Yeah, check your understanding. Which of the expressions are equivalent to this one? Okay, let's see which one is the equals to this one. Days greater than days greater than 365, or days equals to 365. I said with my mouth. And let's see in option, do we have this option in here choosing for choosing? It's saying days greater than 365, true, or days less than, no, this one is false. Days greater than 365, if you put here not, so the conditions in here, let's say days really greater than 365, it is true. Not true will be false. Like days will be less than or equals to 365, and it is wrong. Days less than 365, let's say this is, so let's say this is false because we are looking for greater than or equals. Days less than 365, it is false. Let's say false. And not false will make true, and the expression will change in different way. Let's say this is not, and put in parentheses, not false will be true. It means like days will be greater than 365, 365, or yeah, or days or days equals 360 65. Yeah, guys, we find it. Did you see? Days less than 365 is the false. Like days, if days less than 365, okay, if our conditions is like that. If we say if days not less than 365, it has to be greater than 365 or equals to 365, right? And we're saying if days not less than 365, it has to be greater than 365 or equals to 365, right? That means this one is true. In here, it's saying days greater than 365, it's perfect, and no, it not works. Because we have or in here, okay? Or. So this is working with or. It have to be or. One of them have to be true. We are not looking for both true conditions. It is true, and this is also true, but both of them have to be not true. Like one of them can be true, all right? Maybe in this case, it can be wrong. I mean, all right? So just see that, see and understand that. All right? So in here also, maybe if you remember, then when you put here like not, it will be less than or equal different way. Like days is less than six, like 365. If you apply not for days, like not days, then days will be greater, and not less, it will be greater, and like not 365, it can be equals. So just you can apply all these expressions, my friends. Everything will be nice for you. Just believe me, step by step, you learn all of them. Don't worry, just take your time and think more. All right, we will continue with the equivalent compound booleans. In the second part, I will separate this lesson in the second part. It will be like logical equivalence part one and logical equivalence part two. So this point will be logical equivalence part two. All right, part part two. This is part two. All right, and we will finish it, this topic in part two. All right, so we have a lot. We will make practice, and don't worry about it. All right, I will teach you everything in correct way. Everything will be nice for you, and you will understand everything correctly. So Let's come back to the here. We already learned a lot of things in here, and I hope you understood everything correctly. Just take screenshots for some points. We will continue from equivalent compound booleans, but let's go to the first minutes. We started from here. We made some logical ways to find best solution to write our codes in easier and short case way, right? We just trying to make short with our logical way. So it's all information. All right. This is first part. Let's write here logical equivalence. Logical equivalence part one. And another one is part two. So, okay, we will continue with the part two as soon as possible when I quit a little bit the sickness, like I just want to save my life with it. So when I exactly feel good, I will share another video as soon as possible, maybe after 2 days. All right, it's not more than 2 or 3 days. Just be there. Thank you very much. Have a good time, guys. And thank you for the reaction for my past video, which is for the conditionals like 11.3. 11.8 part 2.3. So I got really amazing reactions, like 100 for like subscribers, like subscriptions, and 4,000 views, like 4,500 views, and 200 hours watching. That's really perfect. Thank you very much. Most of them from United States, UK, and Vietnam, and Turkey and Germany and some countries. I really thank you. I appreciate you. Just follow me and learn everything. You can become a programmer, professional programmer, and machine learning engineer with me. Just watch me. Have a good time. Bye bye, guys.